In this video, we're going to talk about transformations to exponential functions, and I've actually broken this lesson into two different videos to keep it from getting too long. So in this first one, we're going to talk about the different transformations, which are the same transformations that we talked about with lines and with parabolas. So we have reflections, dilations, and then both our vertical and horizontal shifts. And then in the second video, we will talk about like creating the graphs from those transformations. So we are doing transformations to exponential functions. And this is the same thing that is on the top of the A notes. The parent function is some base to the x power. And if that base is greater than 1, we're going to see exponential growth. If that base is less than 1, if it's actually between 0 and 1, I should put that in there, the graph shows exponential decay. So that will still be true for these transformations to the parent function. So here are our 4 transformations. Just like with the other 2 functions that we looked at, when you put a negative sign in front of your function, that is going to reflect it over the x-axis. So this can get a little confusing because in a sense it can turn growth into decay and like negative positive growth. So and there's a little bit of dispute on exactly when it becomes growth or decay because of the reflection. But the main thing that I need you all to know is that if there's a negative sign in front of the function, it is going to reflect it over the x-axis. We can also have a dilation, and that is when we have a number in front of our parent function being multiplied by it. And the effect that that has on the graph is A is going to be the initial value or the y-intercept value. Oops, I spelled that wrong. The initial value is basically the same thing as the y-intercept, assuming there's been no shifts. And so your graph or your y value is going to be equal to a when x is 0. Because whenever we're plugging in a 0 for the x, this part right here is going to become a 1. And so a is going to tell us where it's crossing the y-axis. As far as the rest of the graph, when a is greater than 1, just like with the parabola, it's going to grow faster and it's going to stretch that graph. It's going to kind of pull it taller. You're going to see a more rapid growth. And when a is less than 1, which more technically we're talking about between 0 and 1, so we've got a fraction less than 1, it's going to grow slower, so it's going to look like that graph got shrunk or compressed. You're not going to have as rapid vertical growth. Vertical and horizontal shifts are very similar to parabolas also. So we have our parent function, and if something is added or subtracted onto the end, that is going to create a vertical shift. So if that k value is greater than 0, if it's a positive number being added on here, it shifts it up. And if it's a negative value, if it's less than 0, it shifts it down. A horizontal shift. So just like with parabolas, we had the horizontal shift and it was in the opposite direction of what you would expect, and that's when you had a value added or subtracted to the exponent in the parentheses. Similar concept here, except our exponent is, or our variable is in the exponent, and so it's when we have something added up in the exponent. So when we were talking about quadratics, it was when we had something in the parentheses with the variable. Here, it's in the parentheses with the variable. It just so happens that that means it's in the exponent. And this, just like with quadratics, it moves it in the opposite direction of what you would expect. So if you have a positive value for h, if you have something added, it's going to shift your graph in the negative direction. So it's going to shift it to the left. And if you have a negative value, so something being subtracted from x in the exponent, it's going to shift it in the positive direction. It's going to shift it to the right. So all the same transformations, just on a different graph. And these are transformations that you're going to see and you're going to study a lot in Algebra 2 on all the new functions that you'll see in the future. So this is kind of just laying that groundwork of these 4 main transformations. On the back of this page of notes is kind of like a little cheat sheet of those various transformations, what you would see in the equation, and the transformation that that's going to cause, and it gives an example of each one. I'm not gonna, that's just there for you for reference. It's not extra things that we have to go over in the notes. So this part right here, we have all these exponential functions that have had transformations, and we are going to write the transformation for each of them. So in this first one, we see that our parent function is being multiplied by 6, and then 3 is being subtracted from the whole thing. So we have that dilation with the 6, and since 6 is greater than 1, it's going to stretch our graph taller. It's going to stretch it taller 6 times. So every y value is getting multiplied by 6 as it's growing. And then we also have the transformation, or the translation, of shifting it down. Because it's a minus 3 on the end. So those are the 2 transformations to that parent function in that equation. In the next one, our parent function would be the 5 to the x, so the only transformation is this dilation of 1/2, and that's going to shrink this graph. It's going to grow half as fast. And that's like saying that you're going to multiply every y value by 1/2, so that's why I have that x. That x is meaning multiplication, so times 1/2 there. If you're asked to write the transformation for each equation, I'm looking to see that you can name the transformation that's being done, like a dilation or a translation. You don't have to use the word translation, but I do want you to tell me whether it's a, that it's a shift and in which direction. So like on this one, it was a translation and it was a shift down 3. So let me fix this. I want to write this as a shift down 3. Took that graph and moved it down. For this function, we have something being subtracted in the exponent, which means we're going to have a horizontal shift or a horizontal translation. And we have something added on the end, which means we're going to have a vertical translation or a vertical shift. So 2 translations. One is vertical shift up 8. That's probably actually, the best way to phrase that. So let's edit this. It is a translation, and it was a vertical shift down 3. So you could say vertical shift, translation, vertical shift up 8, and then there's a horizontal shift And since that has a subtraction of 3, it's actually going to move it in the positive direction. So it's going to the right 3. In example 4, we have a dilation. We're multiplying by 1/3. And we have a horizontal shift because we're adding something in our exponent. So this dilation is a value less than 1. So this is going to shrink our graph. It's not going to grow as fast. And it's going to do so at 1/3 of the rate. So each y value is getting multiplied by 1/3. And then we have a translation which is a horizontal shift of 6 in the negative direction, so to the left 6. This function has a dilation of 5. The parent function is the 2 to the x, so it's getting multiplied by 5, but we are also shifting it horizontally because of what's happening up here in the exponent, and vertically because of something being added on the end. So this 5 here is a dilation that is going to stretch our graph. 5. I'm going to make it taller. Each y value is going to get multiplied by 5. And then we have 2 translations. We have that vertical shift of 9. Our graph is going up 9. And we have that horizontal shift of 1, but since it's subtraction of 1, it's going to move it in the positive direction, or move it to the right 1. Example 6, we finally have a reflection. We have a negative sign in front of our graph. So this graph had, the parent function was the 1/2 to the x. It's going to get reflected over the x-axis. Whoops, axis. And then there's a -12 on the end, which means it's going to have a translation. My goodness, I'm having a hard time writing today. Translation, and that is going to be a vertical shift down 11. I'm sorry, not 11. I don't know where that came from. Down 12. It's Monday morning, I'm making this video. I think Miss Loda needs more coffee. So those are our transformations and identifying them from the function itself. I'm going to stop here. There are 6 examples with graphs, and so I will make that in the next video.